Okay, I think I'm going to make a start. We're still missing one of our speakers, but I think I will make a start. So thank you for joining the call. Preventing plastic pollution from AD digestate is our very first webinar. So if we have a few technical glitches or things a bit shonky, just please bear with us. We're learning like I think a lot of people are now. So this is being organised by the BioVale AD Special Interest Group. We've been going for about 4 years now, and we regularly organise events, knowledge transfer events, networking events, site visits for the AD sector in Yorkshire and Humber, and our aim is to stimulate innovation. So I think some of you are already members. If you're not, you'll be given the option to join as one of the follow-ups from this meeting, and I would recommend it. It's free, and I think most people that are members find it very useful. So this was originally going to be one of our regular events. It was scheduled for about a month ago. It was going to be a half-day event, probably with a site visit and networking as well, but we've cut it down to just an hour because of the current circumstances. And the issue that we're addressing here is that plastic can get into the AD feedstock, and then it ends up in the AD digestate, and then the digestate goes onto the farmland. So it's a source of microplastic pollution for terrestrial ecosystems. So we have 3 speakers. We have Fiona Donaldson from the Scottish Environment Protection Agency, who's going to be talking about the regulations in Scotland and why they're there. We have Paul Clark from PRM Waste Systems, who's going to talk about a possible solution at the depacking end. And then we've got David Tompkins from Aqua Enviro, who's going to talk about things you can use your digestate for other than putting it on farmland. And then we'll have a Q&A. So how this is going to work, you should have had your camera switched off by default and your microphone, but if not, if you've unmuted yourself or switched your camera on, unless you're a speaker, please turn them off, because we've got a lot of people on this call, and we can't really manage it if people have their phones or their cameras or their microphones on. If you wish to make a comment, use the web chat facility. You should find that if you go down to the bottom of the screen, it should come up as an option. Don't use the raise your hand. I've been told that's not working for this call. You can ask a question anytime using the web chat, but we'll only get round to them at the end of the presentations. We also have had a lot of questions in. People submitted them when they registered, so we've also got those questions for the panel too. The session is being recorded, and we'll send you the link after the session. Feel free to tweet using AD plastic pollution. I should have mentioned I've got 2 of my colleagues on this call who are supporting me. Alice North from BioVale is going to be supporting Twitter feed. And Alex Hutton from Biorenewables Development Centre is our technical ace on this call. So if you get a problem, technical problem, don't use the web chat, but email him and he'll deal with you promptly. Okay, so we're going to start with the first speaker, and I'm going to try and give her control. There you go, Fiona. You should be in control now.
There we go. Press the right button. Can everybody hear me now?
Yes.
Brilliant. Thanks for inviting me to speak to your webinar. Unfortunately, can't be in person, but you know, we make do. So what I'm going to talk is now. How is that moving? It's not moving. How do we move the slides down? Oh, right, something's happened. Jolly good, right. So what I'm going to do is just present a little bit of the work that SEPA's done. My talk was titled about the regulations to control plastic, but actually what we've done is a lot of non-regulatory work, so we'll go through that, touch a little bit on the research that we've done, and touch on what the next steps we're going to do. See, this doesn't move for me.
Okay. Yeah, so I think I'll have to move it for you. It's still waiting for you to control the screen. So if you just say next slide and I'll move it for you.
Okay, can we move on to the next one? So what we realised very early on in our journey is that the quality of digestate doesn't start and finish at the ED plant. The quality of digestate very much depends on what enters the ED plant, which also depends on what people put in their bin. So we realised that what we have to do is actually take an approach that goes a lot across the chain, and looks at what the producers must do, what the processors must do, and what the end users should be looking for. So we developed some food waste management guidance in Scotland, which looks at the food waste hierarchy, talks very much about prevention of food waste being the first step that you must do, and for what can't be prevented, then it must go for high quality recycling. That's a legal requirement in Scotland, and high quality recycling is defined as going to a PAS 100 composting process or a PAS 110 digestate process. So that's kind of at the core of what Scottish Government wants to achieve through the circular economy work they're doing. So we realised that we need to control the quality of what's arriving at the plant. So the next slide that we did, the next document, was the controls on the input. So that's the next one, Elspeth.
Now I can't control it. I'll abort your control and then I should be able to. There we go.
So what we did then was we looked at the permits that our AD sites have, and we introduced permit conditions to make sure that sites have pre-acceptance procedures for everything that they want to bring in, and that will also include not just kind of standards about weights and where it comes from and what it is, but it'll also be able to determine the contamination rates as well. So sites will be able to know what they're going to accept and roughly what levels of contamination there will be, and it also gives them the powers to reject loads that exceed those contamination rates, and the contamination rates are really determined by what depackaging equipment and what processing the site can do, and it's all driven to meet our PAS 100 standards. So the next document, that's the PAS 100, which is our basis of the end of waste position. Should be a picture of that one. That's one. And we've used that to develop the next document, which is our end of waste position. There's a picture of that one as well. So that's where, so this is our regulation on output. So this is when we will cease to apply waste regulatory controls. And the PAS 110 is the basis of that. So sites must be certified to PAS 110, but our plastics limit is less. Our limit for plastic contamination in digestate is 8% of the current PAS 110 limit. And that was really essentially determined by one of the big quality assurance farm schemes who decided very early on that actually the limits in the PAS 110 were not what they wanted to have in their quality assurance scheme. So they reduced the limits, and since the end of waste is very much determined on what the market wants, we took that opportunity to have our end of waste position aligned with what the market wants to receive. So the next picture is some research that we've been doing. This is research that was done in 2017. We realised very early on that there wasn't actually an awful lot of information out there on what was happening in the soil. So we got some research done to how the plastic behaves in the soil. We tested arable land, we tested grassland, and depending on how it was ploughed in, the research is available on our website. We did find some plastic fragments from the grassland field. There was no plastic fragments from the arable field, but we only looked at particles above 2 millimetres, and there is a very good chance that they had actually broken down by then. And the next picture, that's a more recent piece of work that we've done, and that looked at the plastic contamination. We looked at compost input, but what you have to remember is that a lot of producers don't actually know what process the material is going to. So we reckon that certainly for the food waste and a lot of the commercial waste, the levels of contamination that we found would be the same whether it was going to ED or composting. On the whole, the quality wasn't as bad as we thought it was going to be, but it was still very high, and potentially too high to allow companies to consistently meet the end of waste positions both for composting and ED. And the next picture is a piece of work, next slide. That's a piece of work that was done by a student at the University of Stirling. And this was really to shed more light on the effect of microplastics in the terrestrial ecosystems, because we really were struggling to find some information. So one of my colleagues was involved in this project, and this looked at the impact of different levels of microplastics in soils, and it tested it on earthworms. So she made an artificial soil with different concentrations of microplastics, let some worms do their worm things for 6 weeks, and measured how they grew, how many of them died, and all that kind of thing. And she looked at worm poo, as you do, and looked at what came out the worm at the other end. So what she did show was that, unsurprisingly, the higher the amount of microplastic in the soil, there was a greater weight change, so the worms actually lost weight the higher the microplastic concentrations were, and there were more deaths of worms in the higher plastic concentrations of soil. So not a surprise, not anything that you wouldn't expect to see, but we needed to have the evidence to show that actually this is going to be causing a problem. So the final slide is what we are doing now. So we will we visit premises to check that they have their separate food waste collection, and we also check to see what the quality is like. We check for mixed recyclables as well. So we rely on food waste collectors to tell us people that aren't taking up the service, people that are not using the service properly, and we can anonymously pay them a visit and give, we give them education and tell them what they should be doing, but then we have the power to issue a fixed penalty notice for persistent non-compliance. We are also working with Zero Waste Scotland and industry to look at the steps outside our scope of regulation. So we can work on the ED sites where we permit them, but we really struggle with working with householders and commercial businesses. So Zero Waste Scotland and people like the Renewable Energy Association and ADBA, to see what we can do with getting the message over to householders and commercial producers to educate them as to what should go in the bins, and then educating the farmers and the end users to get the best quality material and to use that material the best way they can. We've also got a land bank report coming out soon, and that aims to look at what the various barriers and restrictions are to using a whole lot of organic materials in Scotland, and it looks at things like climate, topography, but also soil P, soil N, to try to identify areas that really shouldn't be receiving lots of organic material, but also identifying where the opportunities are. So to give us a better idea of where N and P and other things like that are needed. So that's hopefully coming out. We've got a final version with us now, so hopefully it'll be coming out. It's possibly going to be early autumn now, obviously with all the issues that we've had to deal with that took a little bit of a backseat. And we continue to identify further areas of research, to work with other research bodies. We do our own bits on soil and bits on different emissions, but we're more than happy to work with other people on larger projects, especially things like how plastics behave in the soil environment. And we're doing a lot of this through our sector work, which is through the crop sector plan, which will look at the use of organic amendments to soils. So hopefully that's me. I've kept to time, not bad. And the last slide is just my contact details. If anybody wants to get in touch with specific issues, specific questions, we've got a lot of information on the website, but if you can't find it, then either drop a line to me or to our National Waste mailbox and it'll get to the right person. Thank you.
Fantastic, Fiona. Thank you very much for that, and thank you for keeping to time. So we now move on to Paul. Paul, are you there?
Elspeth?
Yes, hello.
Yes, hello.
Do you want to control the slides or do you want to just say next slide?
Yeah, I think if you control it like we did with Fiona, keep it the same.
Yeah, okay then.
Okay, good morning. Thank you for the invite. This is the presentation on the FlexiDry system. Some people from the industry will know of peer-owned waste systems in the AD sector for the Rooney, which is for dewatering. Along the bottom of the slide is some of the other products that we do, like the aerobic small-scale digesters. Next, please. So this has come about by exactly what this meeting is all about, is the reduction of plastics going through the AD systems and ending up into the soils. Next, please. So this is some information that was sent through from FlexiDry, where they currently have their systems working where they're actually achieving below 2% plastics coming through in the digestate. Next, please. So this is the overall view on the left of the FlexiDry while it's in operation. The picture to the right is with the gull wing doors open. It's a simple press of the control panel and the gull wing doors come up on air rams, so you can get access to the process. On the front end, the most important thing you might need to lift the doors for is the ejection of any heavy object or unprocessable object. Next, please. So this is a view through the system. So the product comes into the FlexiDry system on the left-hand side, and the FlexiDry system was developed to be as a soft process, because what we were experiencing with the hammer mill type systems, that all the products were being broken into very, very small fractions. Then that was going through the system and ended up in the AD digestate. By using a soft option, we actually just perforate the product, and then the organic comes out, and then we don't damage it so much. It's basically just had a gentle process on the front end. So talking about the front end, item number one is the perforation. So the product comes up and then it's fed in by a hopper into the perforating area. The perforating area is two rotors which are working together to take the product through, which are rotating at slow speed, and all they do is perforate the products. So the products can be glass, it can be tins, it can be plastic, Tetra Pak, anything it can go through. If we have contamination going in there, so this could be a piece of hard, lumpy wood, concrete metal, the system has a breakaway. So the rotor on the left-hand side will break away, and the contaminant will drop directly through the unit into a skip below. And then as soon as the pressure has been released, it realizes then that it's discharged it. It will then bring it back into process, and then it will start perforating. So the products are perforated now. They now drop inside the barrel of the trommel style system. So now it's going down through, and now you can see item number 2, which is the compression roller. The compression roller is pressing the packaging against the trommel, and this is now squeezing the packaging to release the organic fraction out to come through the trommel and then down through into the sump below, where we can see on the right hand side it says organic matter. On the outside of the system, we also have the brush. So it's actually brushing it to try and keep it clear and keep the product moving, so the system will continually keep processing without any blockages. And we also have a water wash system that we can vary the amount of water going in to the system to keep the system flowing and all the orifices clear to let the organic soup come out. So on the right hand bottom corner underneath, you can see there's a picture of a dough lathe. This is collecting the packaging that's been depacked and washed through the system. And this can be as simple as a dough lathe, as it shows in the picture, to carry the packaging, or most likely it's going to be a hopper, and then there will be a conveyor taking it onto another process. Next, please. So this is a little information about the system. You can adjust the amount of water from the control panel. It's a very, very low water usage, and you can control it to get the optimum washout without excess water going through the system. It's a very, very low power demand system. Hence, that gives us a low electrical consumption, and the combination is a very low operating cost. Next, please. So on the left-hand side, we have some packaging, which is slightly been opened by the look of it, yes. And then afterwards, we have the packaging that's been depacked, and then the organic soup on the right-hand side. As you can see, the packaging is very, very large. It's very open. It's not been smashed into small particles. It's a large particle size. The feeding side of it, you can tip the product directly into a hopper, and all the systems that have been installed have a hopper on the front end, and then that feeds up into the flexi dry system. So this can be tipped in by the pallet load or the dough lathe or a forklift bucket, any way you want to get it into the hopper, and it will handle, as I said, any type of product. It can be Tetra Paks, a pallet of Tetra Paks, it can be plastic containers, glass, metal, in any type of packaging. It will go through and process it to give a very clean soup and a very large packaging on the output. Next, please. So this is a very typical installation where we can see the loader tipping a bucket of packaging product into the hopper. The hopper then feeds it by the 2 screws onto the transfer conveyor auger, which is taken up into the flexi dry, which is then discharged into the right hand side into a dough lathe. We don't see dough lathes as being really the ongoing way to discharge, because it's not a continual process. So all the systems we've looked at so far that have been operational have had an auger and a hopper taking it away. This installation is in a food factory in Switzerland, and they just want to do small amounts, so they're quite happy that they're using a dough lathe to discharge the packaging into. Next, please. So it automatically ejects, as I said, unwanted items by the breakaway system, which is totally automatic. There's software built into the machine, so we can record information about what's going on. It's all on a PLC screen on the machine alongside the control panel. It can also be controlled via a tablet or a phone or anything similar to this. It has a continually cleaning system, and it also has automatic lubrication. So the system is designed, if wanted, it can run a standard 8-hour shift, or if needs be, it can run 24/7. Next, please. This is a design that we put together recently for a project. So the top right-hand side is where the vehicles can tip into, or it can be loaded by a loading shovel or something similar to this. This then feeds down onto another level, which is directly feeding into the top of the flexi-dry. And we still have the breakaway system underneath. So there's a container to take the rejects. The difference in this application is it's showing that the flexi-dry is not discharging to a skip, but it's in fact discharging to a Rooney. The reason we like this system is the Rooney will take even more soup away from the process and get it an even better sample. When we design systems, we design them in SolidWorks, so we can then put it together in the office, we can bring it out to site, we can share it with the customer, and then if the customer wants to move anything around, it can easily be moved around in the drawing in SolidWorks operating system. So the system will work as a standalone flexi-dry. What we like in the way of using the Rooney is that we can run the flexi-dry faster, so it actually gets more output through the machine. And then we can get a secondary cleanup on the pressing, dewatering to get more soup by using the Rooney, which is the red item for the people who don't know what the Rooney is, SK370. And then the 2 green tanks are the holding tanks for then the soup to be held and before it's discharged out to the AD. Next, please. So this is a better photograph of a Rooney system. So the Rooney is a screw pressing operation. So the product comes in the top vertically just above where it says Rooney. It then drops into a screw press. To the right hand side, there's then a basket, which the same as the flexi-dry. It's a 360-degree perforated drum. The screw press then squeezes the organic soup out, which drops into the sump below. This is showing it dropping into an IBC, but in normal applications, it drops into the sump. The sump has a pump, and then the pump pumps onto the AD. The right-hand side, the grey section on the end is the discharge. This is where the packaging will come out, and it will come out as a continual sort of tube section up there that then can discharge into a vessel, a skip, a truck, a trailer, whatever is required to take it on to the next process. And the item just coming back a bit from the right-hand side is where the motor is in the compression medium, so we get more or less squeeze on the output as it comes out. Left-hand side is showing the control panel, and the control panel, the operating system, we can link this system into the flexi-dry, so it's all working continually together. Next, please. So this produces a superior quality soup. It's the systems that we've seen in operation are producing soups of below 2% plastic. It's an industrial technology that was developed in France. It's a simple to use automated process. So the operatives basically just keep loading the hopper, then the system takes over to take it through the system and eject it. As I said, it can run standard 8-hour shifts, or it can run 24/7. In the UK, we have full project support teams. We can design the system in SolidWorks, and then we can share it with the customer on site. It's a very low cost, energy efficient system, but most importantly, it's a soft option, which isn't smashing the packaging into very, very tiny particles before it goes into the AED. Then we can keep it out, and then it keeps the digestate cleaner as it comes through the end of the system. Next, please. This is our sort of relationship with the customer to give them a good solution that we will reduce the plastic that's going through the system to an acceptable level. Next, please. That's it.
Yep. Lovely. Thank you very much, Paul, and stay on the line for the questions in a minute.
Yes, no problem.
Okay, thank you. David, are you there?
I am indeed, thank you, Elspeth. Are you going to hand me control?
I will.
Perfect, thank you. And apologies for my tardy arrival. I didn't actually have a link to the meeting, which is slightly challenging.
It says it's waiting for you to control the screen.
Perfect, thank you. There we go. Okay, so good morning, everybody. It's challenging delivering this remotely because I'm not sure who we've got online. In other words, what you are largely interested in. The rest of the agenda, I'm guessing, is largely focused on challenges associated with food waste, depackaging and plastics in the digestate. When the AD Special Interest Group were putting this webinar together, I was very keen to present a water industry perspective, really just to look over the fence and see what happens elsewhere. The microplastics are not solely a challenge for the waste sector, they are also a challenge for the wastewater sector, but they present different challenges. And my key messages are relatively simple. Keep the microplastics out, or you're not going to have a market. And I'll come back to that in a while. So that's about me. You can find me on LinkedIn if you'd like to. Just quickly about Aqua Enviro. I've worked for Aqua Enviro for just over 5 years now. We were bought by the Suez group of companies just after I joined. We still act as an independent consultancy offering process support largely for the wastewater sector, but also for the bio-waste sector. We aren't beholden to Suez Solutions, and since the 1st of January this year, we've been part of the Suez Smart and Environmental Solutions business unit, but we still retain our own website and our own corporate identity. So you can find out more information on our website if you like. So for those who are not familiar with the wastewater industry in the UK, it's just one slide to show you the growth and reliance on anaerobic digestion within that sector. So over the past decade, we've seen a steady increase in anaerobic digestion of sewage sludges. Most of the resulting biogas is put through CHPs and then the electricity exported rather than biomethane to grid, although increasingly we are seeing biomethane to grid projects within the water industry. And most significantly is this increase in the lighter blue wedge here. That's the increase in advanced anaerobic digestion, so-called. And all that means is that there is some hydrolysis pre-treatment of the sludges before they're put into mesophilic anaerobic digestion. So the AD system itself looks almost identical to a large stirred tank system that you'd have on a food waste site or even a pharma AD site. But here you either got a thermal pretreatment, so that would be a Canby process or a Veolia Biothelis process, for example, or biological hydrolysis. That could be enhanced enzymic hydrolysis, EEH, or the Monsell process, or the Anglian water HPH, heating, pasteurization, and hydrolysis process. Both of those offer pretreatments. Both of them allow biogas to be generated by the volatile solids in the sludges more quickly than without pre-hydrolysis, and it means you have a smaller operating footprint. The key message is most sludges, sewage sludges in the UK now go through some kind of AD process or other. And the little chart to the right here, these are the latest reporting data under the Urban Wastewater Treatment Directive reporting requirements. So these are the sludge destinations in 2016. And you'll see that we are largely reliant on agriculture. So around 75% of treated sewage sludges are being applied to farmland in the UK. In terms of overall tonnage, that's not uncommon across Europe. There are some exceptions, which I'll come back to in a second, but actually the agricultural route is the preferred route. It's the best environmental route for the material at the moment. There is another wedge here, about 100,000 dry tons. So the water industry deals in tons of dry solids, not fresh tons. This is other reuse, and that's largely going to be land restoration. So if you have an issue with access to agricultural land with any kind of digestate because of, for example, physical contamination, then land restoration is an option, but it comes with some very significant challenges. The sites which require restoration are dispersed, you will be charged a relatively significant fee to tip your material on that site. So you can't expect any revenue from your digestates there, but it is an option in some cases. It's not a preferred option, but it is an option. And the other important wedge here, the yellow wedge, that's incineration. And I'll come back to that and say a little bit more in a second. So just a very basic overview of a wastewater treatment works and associated AD, just for those on the call who aren't familiar with this. I'm not going to dwell in any detail, but effectively, imagine this is a waste site. You've got your material coming in on the top left-hand side here. In this case, it's sewage. You screen out the big bits of stuff you don't want. So that's rags, plastics, anything else that anyone's managed to flush down the drain. And then we rely on a series of sedimentations. So the settlers, if you like, the sinkers, come out here. So this is fecal sludges coming out. They go off to anaerobic digestion. And then the water, which is the majority of the flow, then goes off to aerobic treatment here, for example. And then you get some more sedimentation, more solids back to AD. And you may have some chemical dosing here to polish out phosphorus at the back end, and you'll get some chemical sludges, which may then go to AD. So you've got several opportunities to remove contaminants, plastic contaminants and other physical contaminants from the system. Coarse screening here, which may be followed by fine screening. But once it's in the AD system, frankly speaking, you're nerdled. Because we've got, as with commercial AD, we've got dewatering here. This is likely to be centrifuge or belch press rather than a strain press. And the material that's going to land in this case is the cake. So if you've got physical contaminants in your digester, they are likely to partition to the cake fraction or the fiber fraction for commercial digestates, and biosolids are going to land. So if you are partitioning material at this point, at your dewatering point, you could have a problem. So the incentive is to control contamination upstream so far as is possible. The final thing to point out here, the advantage the water industry has over commercial AD, of course, is the liquors. So the liquid fraction is not being tankered off to land, it's going back to the head of the works. So that's actually a relatively small fraction of material that's going out to land as cake. The nature of microplastics will be different in sewage sludges compared with commercial wastes. It's likely to be, for example, microfibers from washing clothes. It could be, if we've got a combined sewer system, it could be fragments of car tires, vehicle tires from road drainage, and also from road markings. The white lines, yellow lines are plastic paints these days, and they fragment and can end up in the sewage system where we've got combined sewer networks. So just a salutary example, what happens if the land bank closes for microplastics or for other reasons? And the example that's often cited is Germany. You'll see here a trend, an increasing trend in incineration of sewage sludges in Germany, and that trend is ever increasing upwards. However, Germany has not banned sewage sludges. It is certainly restricting sewage sludges to land from larger wastewater treatment works. So works that are treating sewage from catchments of more than 50,000 people equivalents, person equivalents. They will no longer be allowed to be applied to agricultural land from 2032, but that's not the entire of German sludge production. It's around 2/3. So the other third could, in theory, still go to agricultural land in Germany. There are also associated restrictions here and requirements. And the material that cannot be applied to land has to be mono-incinerated if it's got a sufficiently high phosphorus content, and phosphorus then has to be recovered from the incinerated ash. So there are some very interesting kind of parallel drivers here. Biosolids not to land, depending on phosphorus, then phosphorus has got to be recovered, it's got to be incinerated. And then also an additional aspect down here about polymers. So polymer oil is widely used for facilitating dewatering in the wastewater sector and elsewhere. Some of those polymers are fossil fuel derived and not particularly degradable, certainly not biodegradable in some cases. So the Germans have instituted a degradation requirement for their polymers. The market is responding by producing bio-based polymers for dewatering purposes, but they are not commonly used at the moment as they are slightly more expensive than the conventional polymers, but they are available. So whether this is the direction that the UK market will follow, impossible to predict, but the key message is a proportion of the sewage sludges can still go to land in Germany, but the incinerator market is much more prevalent there than it is here. So if the land bank does close here, could we incinerate all our sewage sludges? In theory, yes. Sewage sludges are already incinerated in Scotland, Northern Ireland, and in the Thames region in London. Really due to, certainly in the case of London and the central belt of Scotland, lack of proximity for agricultural land. So it's not because the market doesn't want the material, it's just a matter of logistics. You do also have an incinerator at Shell Green, which is currently mothballed. So the direction of travel in the UK certainly has been away from incineration and towards land application of biosolids, because as I said earlier, that's the best environmental route for the material. So if we did see land bank closing, we have an ever increasing fleet of commercial waste incinerators. So these are not mono incinerators in the German sense. They're not just taking sewage sludges. They're taking the residual fraction of household solid waste that can't be recycled. And we do have significant capacity. In theory, sewage sludges could be added as a feedstock into that capacity, but it's never been trialed, and those in the UK certainly, and those facilities have not been designed to take sewage sludges. There are other options, which I'm sure many of you will have heard about. The water industry has been looking at these for a number of years, as has the solid waste sector. Gasification, I think, yeah, over this side, and pyrolysis over this side. Having reviewed the options for a water company client a couple of years ago, we would not recommend advanced thermal conversion technologies because we do not think they are demonstrated at the required scale, or necessarily reliable, or necessarily cost effective. So if you need to go for a destruction route, incineration remains, sadly, the best option at the moment. But there is ongoing interest in gasification, pyrolysis, and other kind of pressure thermal technologies. So how's the water industry responding, not just to microplastics, but to perceptions around the quality of treated sewage sludges more generally? It does have an assurance scheme, so the biosolids assurance scheme, which has a standard associated with it. There is no specific restriction on microplastics within the BAS standard. One could be introduced, but the BAS scheme as a whole does create a very nice stakeholder network. So those that are producing and using sewage sludges, together with those that are part of the food chain taking materials grown on land where sewage sludges are applied, are all involved in the ongoing development and implementation of the assurance scheme. So there is a nice vehicle there to have conversations with the whole food chain around issues such as microplastics in sewage sludges, should it become necessary. Just to note here on the left, UK water industry research are currently looking at quantifying microplastics in biosolids under the Chemicals Investigation Programme, Phase 3. We at Enviro are involved in that project, which kicked off just before the COVID lockdown. Just to note that microplastics in drinking water and wastewater have already been investigated. There are data out there. And also to note the scale of the investment. So this is not just a microplastics investment, it's about chemicals more broadly. So everything from estrogens to plastics to anything else, 140 million over 5 years. So significant amounts of money are being spent by the water industry to understand the levels of contamination in the materials, whether they are a concern to human health or the environment, and if so, what options there are to remove them or minimize them down to an acceptable level. So just wanted to highlight there are options outside the water industry for other markets, but I don't think this is necessarily the best time for this conversation. And ADBRA are having an event, I think next week or the week after, where some of this material will also be available. But yeah, fertilizer manufacture is an option. You do have significant regulatory constraints depending on the feedstocks to your system, and I'm happy to have conversations with any afterwards if you're interested in this in a bit more detail. Just to note, there are digestate-derived fertilizers on the market already. And then animal bedding is an option, but it does depend on your feedstock again, not allowed for dairy cattle. And if you've got waste going into your system, not allowed because of the animal byproducts regulations. And then finally, growing media. Again, regulatory-wise, depending on the feedstocks that go in, you may or may not have a challenge getting your digestates to market. But in all those cases, fertilizer, animal bedding, growing media, if you've got microplastics in those products, you've got a problem. The key message is don't let them in to start with. Just to skip back. So, yeah, here are some typical prices for growing media, 40 or 50 pounds a cube. I'd say, well, why would you do that? Here we've got another digestate-derived fiber, 130 pounds a cube. So that's supplied to householders and other customers as a soil improver. So in terms of margins and market options, there are others out there, but not if you've got microplastics in your system. So take-home messages, final slide, I think. Keep plastics out of your process. I've noticed some comments in the chat box around biodegradable, compostable, soluble plastics. Yeah, absolutely. If the process will remove them itself inherently, so the biology will break them down, fine. That shouldn't be an issue. But at the moment, we're not in that place. In the water side, the alternatives to sludge to land, all other than land restoration, involve combustion or other forms of thermal destruction. So here be dragons, keep the plastics out, then you've got a range of market opportunities with some small regulatory niggles, but please keep the plastics out. Thank you.
Thank you very much, David.
I'll hand back control. Thanks, Elspeth.
Right. Okay, so I'm just going to start off with, we also gave people the option to send in questions when they were registering. So I'll just start with those before I have a look at the web chat. The first question, which I'm not sure who's best placed to answer, is how is the industry assessing the levels of plastic in the digestate? Does anyone feel qualified to answer that one?
I can certainly talk about it from the output side. So as I mentioned before, the PAS 100 and PAS 110 standards both have limits for physical contamination, which not only does that include plastic, but it also includes glass, metal, other things like that. So if you are a PAS compliant certified process, you will be sampling your output every, I think it's something like 3,000 tonnes of production. They all go away for sampling, and you will get a report back which tells you whether you have passed or failed. And that information is then the levels, and it will include nutrients as well, and those levels are then passed on to the customers of that material so that they are fully cited on what they get. Now, obviously, if you're not a certified process, then there will be no requirement to measure. However, in Scotland, if you are using non-PAS compliant material in our waste system, then you will still have to send the information on physical contaminants, and in particular plastic, along with the documentation that you submit to register the use of that material. So we look at it on at the end, you know, the industry does do sampling and monitoring of the end product. There's not, you know, some businesses will do input sampling, but that's not done across the board.
Yes, David?
Just to add to Fiona's comments, there is no formal sampling of microplastics in digestates, as far as I'm aware. The slight issue is that the categorization of microplastics falls across the monitoring boundary for PAS materials, which is set at 2 mils. So microplastics are plastics of 5 mil and below. So if you are above 2 mil and below 5 mil, then as part of the PAS process, you will have the industry will have a good handle on the contamination level. If you're below 2 mil, then frankly speaking, I don't think anyone's got a clue. There are some research papers out there which have started to look at these questions, but in terms of formal monitoring of sub 2 mil plastics in digestates, it ain't happening, is my perspective. Whose responsibility it is or might be to make that happen, we could have a conversation around. In my slides, I illustrated, or I hope I illustrated, that the water industry is taking its potential microplastics problem extremely seriously, and it has put in a program of formal sampling to understand the nature of any problem and how it might respond to that. But on the commercial AD side of the fence, there's a gap.
Okay, I've got several questions here for Paul, asking what percentage of the organic material is recovered, and also what percentage of organic material is captured by the flexi-dry system. And I think there was another one about how fast it is compared to other systems.
Okay, we're getting levels of up to 97% of the organic fraction is removed from the packaging, so that the packaging comes out very clean, and then obviously the organic material goes onto the digester. So it's a very efficient system. There's various ways of setting up the system. As I said, you can run the flexi-dry as a unit standalone. Or if you want to have increased outputs, you can then put a Rooney on the back end, so you can run the flexi-dry faster and then get more secondary dewatering on the back end by using the Rooney.
We've also got some people asking about the earthworm studies, and saying what would happen if the concentrations went up even higher. Do you think it would plateau? Is there any suggestion to do more work on the earthworm studies?
As far as I know, there will be work ongoing, and perhaps not just looking at earthworms. They're a big species. They're quite easy to monitor, but they're not the only species in the ecosystem. So there will be things that will affect earthworms and things that will affect other things. So I do not doubt that there will be lots of research ongoing, not just in the UK but across the world. And that was one of the things that we found quite difficult, is getting a hold of. And David's saying, some research is free to access, some not. It's just very difficult to try to track it down. But I would have absolutely no doubt that is an ongoing area. And as David says, it's not just looking at, it's looking at a variety of sizes of microplastics, and also the breakdown products as well, because that's something that we need to keep in mind.
Yeah, just to add to that, if I might, it's an area of ongoing research. If I were an academic, I would be all over this. I'm sure research councils are throwing money at the problem and will be for the next few years. The challenge is that a lot of the assumptions have been based on the research that's taken place in the aquatic environment, where feeding patterns of crustaceans and other small animals is totally different to the feeding patterns in soils. So it's, earthworms and everything else would consume mineral material that has no nutritional value as part of their natural diet. So the fact that they might occasionally ingest a fragment of plastic, which also has no nutritional value, is probably neither here nor there. So a lot of the research has deliberately overdosed plastics on experimental soils to see whether there may or may not be an impact. So although, and I've said in the chat, I'm very happy to circulate links to papers that I'm aware of. Just I sanction caution when reading those papers, because they, as with all of these kind of preliminary studies, you have to over-egg the pudding to produce an effect. Whether you'd actually see a similar effect in real life, in practice, I'm skeptical about. And let me be clear, the idea of putting plastic on agricultural soils fills me with horror. Absolutely, we should not be doing it. But the evidence and the research is not quite at the point where I think some specific actions can be taken yet.
So we have a very clear message that we need to keep plastics out of AD. Do the panel have any views on what's the best solution? Is it better source separation? Is it better depacking? Is it some sort of pre-treatment? What's the best way to keep plastics out of AD?
I'll go first. This is the problem that we're finding is, obviously, as David said, the best way is just to stop people putting in the bins in the first place. If we could do that, it would be amazing. So we need to work on education, communication. At the household side, you know, that we know there's lots of issues with funding of local authorities. So that's why we're working with Zero Waste Scotland and the trade bodies to work out what messages are needed, what information the local authorities need, how do they disseminate the information? Can we get a little pack drawn up for them to use? Do we do it on a national level? Do we do it on a local authority level? We're looking at all these things, and Zero Waste Scotland and RAP in England are the people that we're working with to help get that message across, because if it's not in the bin to start with, then you don't, unfortunately, have to buy lots of expensive equipment to take it back out again.
But what we're seeing from the front end is the producers of the food, when they want to dispose of this product, they just want it off-site in large amounts as fast as possible. And visiting flexi-dry systems that we've seen in Europe, what seems to be appearing is processing soup kitchen type style plants, where they have a site which is near a major motorway junction. And the packaging comes from the food companies. It's brought into the plant, it's processed, it's then loaded onto tankers as the AD soup, and then the soup is tankered to the AD plant. So if big volumes are coming from the waste from the food companies, it can be processed at the soup plant, and then the soup plant will then deliver that product over to the AD. So then we have the very clean AD soup going there, and the plastic's been recovered by the processing site, which is in between the food processors and the AD plant. This is the thought that possibly will happen in the UK, that there will be these sites built around major motorway junctions, so it can be big volumes processed, and then the plastic and all the other contaminations of metal and glass removed. And then it's a very clean product which is being delivered into the AD plant.
Yeah, for sure. It's a great message, Paul. I think from my perspective, I've seen the growth in the soup market in the UK over the past few years. Initially, early doors, there were some very significant challenges with one or two suppliers to the market who were not necessarily as strict about the input materials as they should have been. The challenge, I think, ongoing is that there is no ongoing monitoring for sub-2 mil plastics. And I think that's my plea to the regulators. We have a relatively good understanding of the greater than 2 mil fraction of plastic material that's going to be in the soup or in the digestate, but below that, there is no driver to measure and monitor. So although ostensibly there's some very good quality soup on the market, do we understand what the sub-2 mil microplastic fraction looks like in that material? There may well be data, which would be great if that could be circulated. That would be fantastic. But yeah, again, just a note of caution that there are still some very significant evidence gaps.
Okay, I've got another question here. How should the water industry and AD sectors work together with everyone in the supply chain on protecting the land bank from plastic? If one party causes a problem, could everybody lose the land bank?
Yes. And that works both ways. Just a personal example, we did some work a couple of years ago with stakeholders in Scotland who had created a lot of trouble for the Scottish government and the regulators around sewage sludge being applied to land around their properties. But actually, it transpires that that was probably food waste digestate. But we don't really know, because no one was really keeping a handle on what was going where. So my suggestion would be, there should be nothing to be afraid of here. Recycling digestates, sewage sludges, other materials to land for agricultural benefit is a very positive thing to do, and we should be encouraging it, and there should be nothing to be scared of. So I know some resource management companies are very good at engaging with their local communities, either through Twitter or other social media, and letting them know when spreading activities are going to be taking place. So if we could be a little bit more open about what we're doing, promote the benefits collectively across sectors, and engage with householders in areas where recycling activities are happening, I think that would be a very good thing. Whether there are forums, cross-sector forums, to kind of facilitate that kind of conversation, I don't think there are at the moment. So that's perhaps something that we can take out of this meeting to give some thought to, Elspeth.
Yeah, right, yeah. So I think probably I'd like to finish off with giving each of the panel a chance to just share your closing thoughts or your take-home messages before we wrap up. Fiona?
I hate having to go first. I guess, from our point of view, the application of digestates and biosolids to land is a big part of the circular economy. It does provide very useful nutrients and much needed organic matter to the soil, which we know that we're losing. We just want to make sure that it is the best quality that it can be. Yes, 0% would be great. I don't think we're ever going to get there, but we want to make sure that we want it to continue to happen, but we don't want this to be done to the detriment of the environment. And it's not just the soil; it also goes into the water courses as well. So yeah, we're all for removing plastic from all stages of the process.
Paul?
As a supplier of solutions with equipment, we would like to see a change in some of the thinking towards the front end of depacking on AD plants, and a move away from high-speed, hard processing, which is breaking all this packaging into microfine components, which is coming through the system, to actually slow, soft systems, which are basically just really gentle on the packaging, so we don't have the problem going through. And then maybe the answer is, like we discussed earlier, that there's actually, rather than having depacking at the AD plant, that there are these soup sites set up so they can produce the soup, and then that can be delivered into the various sites. For example, I visited a site in Lyon, France, where this company has 4 soup processing sites across that region, and they collect in the food packaging, they process it in time that they're not under pressure to get more and more through. It's all about the quality and making sure that the packaging, predominantly the plastic, isn't going through the system. And they produce a very, very high quality soup that then goes to the AD, and then they deal with the packaging at the soup processor. So none of us want to lose the land bank. We want to be able to use this product on the land and the benefit. So it's all about trying to get the packaging out of the soup before it goes into the digester and benefit everybody.
David?
Yeah, I'll give a slightly different response, and it's plastics are great. Plastic is a fantastic material. It just so happens that through a range of reasons associated with consumer practices, lack of education, lack of infrastructure, lack of regulatory oversight, lack of policy drive, those plastics sometimes end up in the wrong place. So kind of stepping back, there is a much bigger conversation to be had about how we handle plastics as a society, because they are fantastically versatile materials. And we would, I think, jump to any conclusions about cutting plastics out of use as a broader society at our peril. So yeah, by all means, do not put them in digestion systems if they do not digest and are not designed to be digested. Otherwise, let's think about more creative opportunities to retain value in plastic.
Thank you very much. And in fact, that point kind of feeds into another event. We're in the very early stages of designing, which is going to be an event on sustainable packaging for the food manufacturing industry. So if they've got packaging that's actually keeps the food good but is compatible with the AD systems, that's another possible route in. So I'd like to thank everyone very much for taking part. That was a bit nerve-wracking, but more or less went as planned. I see we've had a request to share the web chat as well as the actual recording. So we'll look into whether we can do that. And also some requests for the earthworm study references. So we'll also share those with you. I think Alice will be in contact with both speakers and participants to get for feedback from you, and we would really value that, because I said this is our first time. But thank you very much, everyone, particularly the speakers, for taking part. Thank you.
Thank you for organising.
Bye.
Bye.
Bye.